All right, everybody, welcome back. Today, what we're going to take a look at rational equation applications. All right, so these previous couple weeks we've been working on solving rational equations, so now we're actually going to apply them to real situations. Now, there's two main types of problems that we're going to be taking a look at, and that's going to be average and what we call work problems. Average problems are exactly what they sound like. You're going to need to calculate the average of something. All right, so in order to do that, to calculate the average, you find the total of what you're interested in, whether it's a test score or the cost of something, and you are going to divide by the number of items in question. So, for example, if we're trying to find the average of test scores, you add up all the test scores and divide by the number of tests. If we're finding the average cost, you take the total cost and divide by the number of items. All of those problems are going to kind of stem around this general equation, that average is going to be equal to the total divided by the number. All right, so that should be something we're pretty familiar with. You know, averages utilized in a bunch of different things that we see quite often. But then we have what we call work problems. Work problems are a little bit more new to us. So it's important to remember that somebody's work, the amount of work that they can do, is dependent on two things. Is dependent on their rate, how quickly they're getting stuff done, and then it is dependent on how much time they put in. So work is going to be equal to the rate times the time. All right, and just to kind of give you a perspective on that, you know, if you're working towards something but you're working very slowly, your rate is going to be very low. So it's going to take you a lot of time to do it. Now, the same works inversely, right? If you're working very quickly, then the amount of time you're going to spend is going to go down. All right, so really for these work equations, what we're going to do is we're going to get a couple different situations where we are going to need to calculate one person's work and another person's work based on the information we're given, and then the problems are going to be structured a little bit differently depending on what we're looking for. All right, so those are the important things to remember for each one. Let's take a look at a couple examples. So for this first one, it says the cost of a manufacturing company. It costs a manufacturing company $8 to produce one can of paint. If the initial investment in the product line was $50,000, how many cans of paint must be produced so the average cost per can falls to $10? Well, there's some key information here. First of all, it costs $8 to produce one can of paint. So for every can that they create, it is going to cost them $8. But then they also paid an initial amount or initial investment of $50,000. And then finally, we want our average cost per can to fall to $10. So this is average, right? We see average in here right there. That means we want to calculate the average cost. Okay, so let's think about what goes into the cost of some of these products. What goes in is, first of all, we got to remember that it's going to cost, and I'll do this in purple, $8 per can. Now, we don't know how many cans we're supposed to make. It says how many cans. That's part of the question, so that's what we're going to calculate. So to represent an unknown value, we are going to use a variable. So it's $8 per can, but we also can't remember that there is an initial cost of $50,000. That $50,000 went towards the initial investment in the product line. So this is our total cost, and just like what we did above, we have the total divided by the number. Well, we don't know how many cans we're going to sell. We don't know what X is, so I'm going to leave our denominator as X. But what we want is this to calculate our average cost, which it should, right? The total cost is our numerator. The number of cans is our denominator. That should give us the average cost. So this is the equation we're going to use, but we want the average to be equal to $10. We want to fall to $10. So what we're going to need to do is solve this equation for the X value that would make this equation equal to 10. So in order to do that, we need to use our inverse operations. Instead of dividing by X, I am going to multiply both sides by X. And we get 8X plus 50,000 is equal to 10X. And then I'm going to need to get all of my variables on one side. So I'm going to subtract 8X over. And we get 50,000 is equal to 2X. And then I'll finish over here. 2X equals 50,000. I like my variables to be on the left side of my equal sign, and because these are equal to each other, you can flip-flop places. So I'm going to isolate that variable, divide by 2, and I get x equals 25,000. Now we need to remember what we're talking about. The question says how many cans, so the answer of 25,000 needs to be in the correct unit, which is cans. So if we sell 25,000 cans, that will bring the average cost down to $10 per can. All right, so this isn't typical average problem. It's basically how it's going to work. We calculate the total value of what we are interested in and divide by the number of items. Now we had an equation here because we didn't know how much the total was going to be. We knew there was an initial 50,000 and then we knew there's an initial $8 per can, but we didn't know how many cans we were going to have, which is where our variable comes into play. And we're going to divide by the number of cans, and we didn't know what that was, so that was our x value in our denominator. Up next, we have our work problems. All right, so work problems are going to be a little bit different. It says Brian can complete a certain task in 10 hours. Jamie can do the same task in only 8 hours. If they both did the job together, how long would it take? All right, so let's think about this for a second. So we have how long it would take Brian to do it on his own. That means Brian's rate is going to be 1/10. And the reason that is he can complete one task in 10 hours. That's why it's 1/10. All right, now Jamie can do the same task in 8 hours. So Jamie's rate is going to be 1/8. All right, so we want to find out how long it is going to take them together. We don't know the time. So if we're trying to figure out the work that Brian is going to do, we need to take his rate times the time, which we don't know. Jamie's is going to be the same idea. Jamie's work is going to be her own rate times time. Well, the goal here is for them to work together. So the work of Brian plus the work of Jamie should equal one completed job. That is our goal here. We take Brian's work and Jamie's work, we add them together, and boom, the job is done. So what we need to do is solve this equation. Since we are multiplying here, the t's are going to go into our numerator, and we'll end up with t/10 plus t/8 is equal to 1. Well, if I want to add these two values, their denominators need to be the same. So we need to think about the smallest value that both 40 and 8 multiply into, and that is our least common denominator, and that is going to be 40. So I multiply by 4/4 over here, because then we get 4t/40, and I'm going to multiply this side by 5/5, and we will get 5t/40. All right, now because their denominators are the same, we can add them together to get 9t/40 is equal to 1, and we can solve for the time that will make this true. So using our inverse operations, I'm going to multiply both sides by 40. We'll cancel my denominator. I get 9t equals 40, and then I'm going to divide by 9, and I get t equals, well, let's see if we can divide 40 by 9. It should be a little bit more than 4. We end up with 4.44. And the reason I did 2 decimals, technically it's 4.444 repeating, but we are talking about time, so this should be 4.44 hours. That is our answer here. All right, so that is a pretty typical work problem. We are going to look at one more because these can be a little bit different, but for the most part, it's going to be set up just like that. We find the one person's work, and then we find the other person's work, and we remember that they're working together, so we should add the work together to get one completed job. All right, so it says Jane can paint one house in 3 days. So there's our first rate. Jane's rate is 1/3. And then it just jumps to when Becca and Jane work together, they can paint the house in 2 days. So Becca and Jane can do it in 2 days. So how long would it take Becca to paint the house alone? All right, well, let's use the same idea we had before. We have Jane's work is going to be 1 over 3 times whatever the time is. And then we have Becca's work, which we don't know what her rate is, and then we have time. So we're going to need to add these things together to get one completed job. 1 over 3 times t plus 1 over, whatever the rate for Becca is, times t should equal one complete job. So the problem here is we've got a lot of variables. We have r and t, and we need to try to solve. Now what they do tell us at the end here is that when they work together, it takes 2 days. So that means the time is going to be 2. So what I'm going to do is replace time with 2. So my equation will become 2 over 3 plus 2 over r should be equal to 1. And we are solving for Becca's rate. So exact same setup as before. There was just some slightly different unknowns, okay? So we plugged in the extra information we were given, which in this case was the time it takes them together. And now we can solve this equation. So we need a common denominator. So I'm going to multiply my left part by r over r. And then my right part, I'm going to multiply by 3 over 3. And that's because my least common denominator is going to be 3r. All right, so this one had the 3, I was missing the r, so I multiplied top and bottom by r. And this one had the r, I was missing the 3, so I multiplied top and bottom by 3. So this will simplify to 2r over 3r plus 6 over 3r equals 1. And now we can solve. So I have 2r plus 6 over 3r equals 1. By isolating my variable, I can get it out of the denominator. So I'm going to multiply by 3r. And I get 2r plus 6 equals 3r. Last but not least, let's get our r on one side. So we get 6 equals r. So therefore, if Becca worked alone, it would take her 6 days. All right, and we got to remember that our unit of time here is days, which is where my days came from at the end. Okay, so again, a similar problem, same setup. We are given the rates, of each person, and we created how much work they could do. We started with that equation, and then we remember that Jane plus Becca should equal one completed job. Now the difference here is I didn't know everybody's rate. I didn't know what Becca's was, but I did know the total time it would take them together, and that's what T is going to stand for. So I plugged in for T there, and I just solved for a different part of my equation, which led me to my final conclusion. Okay, so these are the two main problems we're going to look at. We have average and work, and they should work just like this. If you have any questions or concerns, as always, please feel free to let me know and leave a comment below. Okay, thank you.